What if everything we think about what causes motion in the universe, like gravity or inertia, is actually backwards?
Really? That's a bold claim. So you're saying gravity isn't what gets things moving?
Exactly. It turns out gravity doesn't start motion at all. Instead, motion begins with something called a pressure impulse, a sudden, powerful push.
Huh. That's surprising. So why does this matter? I mean, does it change how we understand planets and galaxies?
It absolutely does. If motion starts with these bursts of pressure, not gravity or inertia, it reshapes how we see the formation of everything, from planets to galaxies, even the universe itself.
Okay, I'm intrigued. So what exactly is this pressure impulse?
Think of it like this. When matter is under intense pressure and suddenly releases that pressure, it creates a burst of energy, a pressure impulse, that pushes matter outward. Imagine a volcanic eruption or a star exploding. That sudden push sets things in motion.
So without that initial push, matter would just stay still? Gravity can't get it moving on its own?
Right. Gravity pulls, but it can't start motion. It's like a ball sitting on a hill. Gravity pulls it down, but the ball won't move unless someone gives it a shove. That shove is the pressure impulse.
That's a great analogy. So gravity's role is more like, guiding motion rather than creating it?
Exactly. Gravity is a continuous, universal force that pulls matter inward, but only vertically, straight toward the center of mass. It can't create or sustain sideways or orbital motion. It just bends or curves whatever motion already exists.
Wait, so when planets orbit the sun, their sideways motion isn't caused by gravity?
Nope. Their sideways or tangential motion comes from the initial pressure impulse that pushed them. Gravity just curves that motion into an orbit, like a guide rail.
That's wild. I always thought gravity was the main driver of orbits.
It's a common idea, but Galileo's experiments showed gravity acts only downward, not sideways. So gravity shapes the path, but doesn't push objects forward.
So how does this pressure impulse idea explain the structure of the universe, like galaxies and solar systems?
That's where the massive mass ejection theory comes in. The universe's structure forms from repeated massive ejections of matter, pressure impulses that fling matter outward with momentum. Gravity then bends these straight-line motions into orbits and stable systems.
Can you give an example?
Sure. Take our solar system. It formed from a single massive ejection from the sun, which expelled matter at different speeds and directions. Lighter matter traveled farther, forming the outer planets, while heavier matter stayed closer.
So that explains why the solar system is mostly flat and disc-shaped.
Exactly. The initial ejection favored a plane, and gravity shaped the paths into orbits. This model explains the solar system's structure without needing ideas like space expansion or mysterious forces.
Interesting. How does momentum fit into all this? I know physics talks a lot about inertia.
That's a key point. Inertia is often described as an object's resistance to change in motion, but it doesn't explain how motion starts or changes. Momentum, on the other hand, is the real, measurable quantity that carries motion. It's created by the pressure impulse.
So momentum is like the actual stuff of motion?
Exactly. Once matter has momentum, it keeps moving until something like gravity or friction slows it down. Momentum is directional and variable, while inertia is passive and constant.
That really shifts how we think about motion. What about the solar system itself? How does this theory explain its formation in detail?
The sun once violently ejected a small percentage of its mass, somewhere between 0.2 and 2%, at high speeds, hundreds of kilometers per second. This ejected matter became planets, moons, asteroids, and comets.
Wow, that's a huge amount of material flying out at incredible speeds.
It is. Gravity then curved their paths into orbits, and their spins and tilts were set by the chaotic nature of that initial ejection. This single event explains the solar system's structure and dynamics better than slow accretion or collision models.
That makes sense. And I guess that's why Earth's motion feels so smooth. We're just moving along with that initial momentum shaped by gravity.
Exactly. Earth's spin and orbit are fossil records of that initial push and gravity's shaping hand.
So if galaxies and stars move because they were pushed by these massive ejections, does that mean the idea of space itself expanding is wrong?
According to this view, yes. Galaxies drift and accelerate outward because of recoil effects from repeated ejections, not because space is stretching. Gravity shapes and restrains motion, but doesn't create it.
That's a big challenge to the Big Bang and expanding universe models.
It is, but it offers a mechanical, observable explanation based on pressure impulses and gravity, rooted in real phenomena like explosions and ejections.
I like that. It feels more grounded in what we can actually observe and reason about.
Exactly. It reminds us that science should start with observing real events and reasoning logically, not just building abstract models.
So next time I think about planets orbiting or galaxies moving, I'll remember they were set in motion by powerful pushes, not just gravity pulling them along.
That's the takeaway. Motion in the universe begins with pressure impulses, momentum carries it forward, and gravity shapes the path. It's a simple, physical picture that changes how we see the cosmos.
Fascinating stuff. Definitely gives me a new perspective on the universe.
Same here. It's amazing how a shift in understanding motion can reshape our whole cosmic story.